Hello, today I'll be proving this equation right here. So what we have here is a plus b cubed. For reference, this will be b, and this would be a. B is one length and a is two lengths. So what we know is this is a plus b, which is three lengths. So at first, to make this true, to make a skeletal frame of this, we must do a plus b times a plus b times a plus b right here. And I will change it to this. So our next plan of action is to fill out this cube area of a plus b times a plus b times a plus b with this equation right here, which is a squared times 3a squared a cubed plus 3a squared times b plus 3ab squared plus 3 plus b cubed. So let's begin. First of all, the first thing I want to do is get rid of both the a cubed and the b cubed. We know our b cubed is going to be this for a reference, where everything else was built off of. So that gets rid of our b cubed. This central part is b cubed. So first thing we must do now is to cube our a. I'm going to be choosing this side to cube. So that gets rid of a cubed in total. Now, next we're going to move on to the 3a squared times b. And I will use this side to demonstrate. So we know this is a right here, this front, and this is b right here. But we also know that since this is also b, because this is b cubed, this back part must also be b, which means that what 3a or a squared times b really is a times b in a 3D sense. So what we can do is first we can multiply by a to get the surface right here, which is a times a, 2 times 2, and then for the width we can just do a casual b in order to make it still times by b. And we will repeat this one more time for our example with this side. We know this is a, and how do we know this length is b? Well, we know this length is b. So how do we know this width is b, to be exact? Well, we can look at the front. We know that this total is a plus b. We know that this was a and this is b. Well, what we can also do, since the commutative property applies, where order doesn't matter of how you add it, is this could be a, and then this could be b, and it still equals to a plus b. And we know one side is b and one side is a. We just switch them over to get the width of b right here. And the same thing with the previous a's right here. We square it and times it by the width of b. Sorry. Rough edge on cube. And now we've gotten most of our cube complete. I'm going to now say that this is now an a squared times b, a singular one. Let's keep that in mind. Now I want to get rid of these ones, 3a times b squared. Well, we've already gotten rid of one of them actually. So just like the a squared times b, what a times b squared is practically a times b times b. Well, this is a great example of a times b squared, because it is a singular a times b in width times b in length, making it a times b times b. And we're going to apply this to our top cube pieces, which first we'll start off knowing that this is b and this is a. We can just do a, which we know this is a because this part is a cubed, times this b. And we're going to do the same thing for the other side. Excuse me. There you go. Knowing that this part is a, because it is a squared, times b, and knowing that this is b, we're going to do a times b times b. A times b, times b times b. So those three are gone, 1, 2, and 3, leaving us with the final and marked a squared times b. What we know now is this is a squared, this is a, and this is a, which means this remaining area has to be a squared. And what we also know too is that this height is b. So a times b leaves us with a squared times b, which completely fits and makes the cube that is a plus b, or a better example is a plus b times a plus b times a plus b. And the full cube is completed, adding all these different parts together.